Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 2-3 is savings accounts. Okay, example 1. Oh, by the way, there's all kinds of definitions, vocabulary words. A savings account is an account that you put money in to save money, hence savings account. Get it? Okay, savings accounts don't have very good interest rates these days because the interest rates on loans is low. Banks are in business to make money. So if they lend money at, say, 3%, they can't give you 3% or more on savings accounts because they wouldn't be making any money. So the savings account interest rates are always well below what interest rates are for loans. So they profit. Interest rate is the rate at which we make money. Okay, it's a percentage. Principal is the money we start with. An annual percentage rate, or APR, is how much we make on an account or be charged on an account annually. Simple interest is just that. It's interest on the principal only. It's not interest on interest. And we'll get to that, which is called compound, in another chapter. And then there's a simple interest formula we'll talk about this chapter. Statement savings, minimum balance, money market accounts, CDs or certificates of deposits. Those are places you put money and they have to stay there for a period of time, usually years. Maturity is when a CD becomes mature and you are allowed to withdraw from it or get your money back from it. And an arithmetic sequence is something that we're going to talk about. It is an Algebra 1 concept, and common difference is part of the arithmetic sequence, finite and infinite as well. Okay, so here we go. Example 1, Lisa has a glass jar in her office that she's going to use to collect coins. She starts by putting $11.25 into in coins she already has. So she's starting off with $11.25. She pays for her commute to work each day and gets 75 cents in change. So her commute is $1.30 or $2.30 or $3.30, something with 30 cents in it, because she's getting 70 cents back in change when she pays for her commute at a toll booth somewhere. She will add the 70 cents into the glass jar each workday. After 100 work days, she'll take all the change and put it into her bank. How much will she save, or how much will she have after 100 work days? So since Lisa is adding $70 each workday, the common difference is 70 cents. So common difference means how much does it change every day? It's common because it doesn't change. And when I say change, I don't mean coins. Okay. 0.70 every day makes it common difference. Okay. The first term is the first day contribution, which is $11.25. And for the remaining 90 days, she'll add 70 cents to the jar. She needs to find the nth term of her arithmetic sequence. And so I'm just going to go over this quickly. It's a review from Algebra 1, as I said. So since Lisa's adding $70 each workday, the common difference is 70 cents. First term is $11.25. Remaining 90 days, 70 cents will be added. She needs to find the nth term. So an arithmetic sequence is a sub n, n being the number of terms in the sequence, equals a sub 1, which is the first term, plus the number of terms minus 1 times the common difference. So since we're looking for the 100th day, n is 1. Since she has $11.25 and change, that is our starting amount. Okay. So that is her first day's contribution, plus 100 minus 1, n minus 1, since n is 100, it's 100 minus 1, times 0.70, the common difference of 70 cents per day. So when we solve that, we get a sub 100 equals this, and therefore a sub n equals $80.55. So after 100 work days, Lisa will have $80.55. And it says here, note that if Lisa was removing 70 cents from the jar each workday, the common difference D would be negative. All righty. So now there's a check your understanding. Pause your video, see if you can use this formula and see how you do. All right, so here we go. An arithmetic sequence has a first term of 25. So this is my A. What did I choose up here? Okay. Pen. All right. The first term has a first term 25. First terms are A sub 1. And a common difference D. Common difference D is 3. Find the 50th term. This is our n. So I write the formula. A sub n equals A sub 1 plus n minus 1 times D. You should always write the formula so you get a feel for it, so you remember it. And then our n is 50, so we're looking for A sub 50. And that is going to equal A sub 1, which is 25, plus 50 minus 1 times our common difference 3. So A sub 50 is going to equal 25 plus 49 times 3. Don't forget order of operations. You do inside the parentheses first, then you multiply, then you add. So this is going to become A sub 50 equals 25 plus 9 times 3 is 27, 4 times 3 is 12, plus the 2 is 14, and then therefore A sub 50 equals 7 and 5 is 12, 4 and 2 is 6, and 1 is 7, and 5. Whoops, I'm sorry. Not 5, 1. Okay, 172. So $25 plus 147 is, oh, I don't know their dollars. 25 plus 147 is 172. Okay, so A sub 50 equals 172. All right. Continuing, it says find the common difference for the infinite arithmetic sequence shown below. So this is an extend your understanding. So this is my first term of this sequence. So that is A sub 1. And now I need to know what the difference between these two is. 11 to 23 is a difference of 12. And check to see that they're the same. 23 plus 12 is 35. 235 plus 12 is 247. So the common difference is definitely 12. 247 plus 12 is 259. So this is our D. So the formula is A sub n equals A sub 1 plus n minus 1 times D. I know A sub 1 is 211, so I'll put that here. And then the number of terms doesn't change. We don't know because it goes on forever. Okay, and it's n minus 1 and times D. So A sub n equals 211 plus n minus 1 times 12. Okay, I just did the whole thing to set it up. And then if we're looking for a number of terms, if I plug in a 2, we should get 223. And if I plug in a 3, we should get 235 and so on. All right. But what's the question say? Find the common difference. So it is D equals 12. So I explained a little more than what was asked there, but there's nothing ever wrong with that. Okay, example 2 says Grace wants to deposit $5,000 into a certificate of deposit. That's what CD is, for a period of 2 years. She is comparing interest rates quoted by 3 local banks and 1 online bank. Write the interest rates in ascending order. Which bank pays the highest interest for this 2-year CD? Okay, so, whoops. What you're going to do here is we put the numbers in ascending order, which is least to greatest, and convert the fractions to decimals and then compare. So it says to convert the fraction to an equivalent decimal, divide the numerator by the denominator. Or we could say, well, 4 times 1, or 4 times 1 is 4 plus 1 is 5. 5 divided by 4 is 1.25. 8 times 1 is 8 times 3 is, or plus 3 is 11. 11 divided by 3 is 1.375 and so on. And 1.250 is 1 1/4. And we added a 0 to it because there's 3 decimal places in this one. And then we have 1.22 and we put a 0 at the end, and 1.300 to put a 0 at that end there. So what we did there is just simply made them 3 decimal places, 10th, 100th, 1000th, 1.375 thousandths of a percent. Okay, all these are in thousands. Then write the original number in order from least to greatest. So 1.220 is the smallest, and then 1.250 is the next, and you put it back into the original format, 1 1/4%. And then 1.300% is the next, so that's 1.3%. And then finally, the largest one is 1.375%, which is 1 3/8. So you put it back in the standard. So E Savings Bank with 1 3/8% pays the highest interest on a 2-year CD. Okay, check your understanding. Write the following 5 interest rates in descending order. That's greatest to least, by the way. Notice it said descending order, and this one said ascending. Be careful with those. Descending is greatest to least. So pause the video, see if you can do this. And here we go. So this is 5.51%. This is 5.5. What I will do is that's 5.5. Okay, 5.5%. And 5/8 is 5 times 8 is 40 plus 5 is 45. 8 goes into 50, so that'd be 5. 8 goes into 5, it doesn't, so that's 0. Actually, it's more than a half, so it's point something. So 8 goes into 50. Point times, yes, 7 times 8 is 56, 6 times 8 is 48, so it's going to be 6. There's a remainder of 2. 8 goes into 22 times, which is 16, a remainder of 4, and 8 goes into 45 times, so it's 5.625%. Okay, so now we have 5.5%, 5.625, 5.099%. I'm not going to change that, and 5.6%. So they're now in percents. Now I want to make sure that they all have 3 decimal places. So it'll be 5.500%, 5.625%, 5.099%, and 5.600%. Okay, greatest. 5.5, 5.6, this is greater than that. 5.62, 5.0, 5.6. This is the largest. 5.625% was the 5 5/8. So listing them in greatest or descending order would be 5 5/8%, followed by 5.600, which is 5.6% in the original format. And then we go to 5.5. Oh, I forgot my 5.51. So this is 5.5100% with the right number of decimal places. 3, no, it's just 1 0. Just kidding, just 1 0 here. Okay, and then let's get back to this. So 5.6, and now I have 5.51, which is more than 5.5, so that'll be the next one. 5.51%, followed by 5.5%, and then finally 5.099%, descending order. Okay, page 3, example 3, whatever you want to call it. Raul, his savings account must have at least $500 in it. Okay, that's a minimum. He has to have at least 500 in it, or he'll be charged a monthly $4 fee. His balance was $716.23 when he withdrew $225. What was his balance after the withdrawal? Okay, so what you do here is you subtract the withdrawal. So you had a balance of 716, you subtract 225, that brings us down to $491.25 or 3 cents. That is obviously less than $500, so he will be charged a $4 fee. And so $491.23 minus $4 is $487.23. So Raul's balance after the withdrawal and penalty is $487.23. Okay. Kind of have difficulty accepting an account that would do that, because if he does not make a deposit the rest of this month, next month it's going to cost him $4 again. So he better get $8.77 in there between now and the end of the month, or they're going to charge him another $4. Okay, so anywho, so now it says check your understanding. May has $891 in her account. A $7 fee is charged each month. The balance is below $750. She withdraws $315. If she makes no deposits or withdrawals for the next X months, express her balance algebraically. Okay, so what I'm going to do here is I'm going to take her balance of $891. And it says right here that she's going to withdraw $315. So if I take $315 away from that, then I get $576 in the account after the withdrawal. $576 is obviously below $750. Okay, so if she makes no deposits or withdrawals for the next X months, express her balance algebraically. So you take the amount she has in her account after she withdrew the $315 and you subtract $7 times the number of months she does not make a deposit. So in other words, if she does not put $124 in that account, they're going to charge her $7 a month. So it's going to keep getting smaller and smaller. It'll go from 576 to 569 to 562 to 555 to 548 to 541. Just keeps taking it and taking it and taking it, charging her $7 because she doesn't have a minimum balance. And this is the algebraic expression. Example 4 says Mitchell deposits $1,200 in an account that pays 1.5% simple interest. Okay, keyword here, simple interest. All right. He keeps the money in the account for 3 years without any deposit or withdrawals. How much is in the account after 3 years? Okay, so now we're getting to the formula for simple interest, and that is I for interest equals P for principal times R for the interest rate times T, which equals time. I equals PRT. So the way I do it in class is, or anytime I do this, I write all the variables down over here off to the side, and I enter what is given. That is the first thing. The deposit of $1,200 is going to be the principal amount. So I put that right here for P. Okay. The 1.5% interest I want to put as a decimal. So I'm going to call that 0.015. Okay. We want percent in decimal form because we're going to enter in our calculators. And he keeps the money in the account for 3 years. Simple interest is compounded annually, and you just use T equals the number of years, which is 3 in this case. So we have 3 knowns, 1 unknown. We can answer this problem. So you write the formula, you substitute the givens. So it's going to be 1,200 for my P. My R is 0.015, and my T is 3. Then I'm going to multiply those and I will get a value. So I open my calculator up and I put 1,200 times 0.015 times 3. Enter, and I got 54. So the interest is $54. And that is what the question asked. How much is in the account? Oh, it's not asking that. So I always go back and read what the question asked. How much is in the account after 3 years? Well, he put $1,200 in for principal, and you take the principal and you add the interest. And the interest was $54. So therefore, at the end of 3 years, he'll have $1,254 in the account. So this is the answer to the question. Okay, that's that. So check your understanding. How much simple interest is earned on $4,000 in 3.5 years at the interest rate of 1.2%. So here we go. What do I do first? I equals PRT. Over here, I write I equals P equals R equals T equals. Once you do this a couple of times, it gets routine. What are we given? How much simple interest is earned? So we're trying to find I. The principal's 4,000. So I put 4,000 here. 3.5 years, I'm going to put 3.5 for the length of time. And an interest rate of 1.2%. Move the decimal 2 places to the left. That will be 0.012. You substitute that into the equation, and that's going to be 4,000 times R, which is 0.012, times T, which is 3.5. And that is going to give me a value when I plug it in my calculator, 4,000 times 0.012 times 3.5. Enter, and I get $168. It says how much simple interest is earned. It did not say how much is in the account. I am done when I answer this. Okay, and that's that. All righty, example 5. How much simple interest does $2,000 earn in the 7 months at an interest rate of 2%, round to the nearest cent? The key word here is still, again, when you see simple interest, you write I equals PRT. You get into the habit of doing it. I equals P equals R equals T equals. $2,000 is my principal. How much interest? We're trying to find this. 7 months. Time is usually in years, so you're going to put 7 over 12. There's 12 months in a year, 7/12 of a year. Make sense? And then the interest rate of 2% is 0.02 when you move the decimal 2 places to the left. Substitute in the givens. I equals P is 2,000. 2,000 times R, 0.02 times T, 7/12. Okay. I equals calculator. 2,000 times 0.02. Then I'm just going to do parentheses, 7 divide 12 in parentheses, and hit enter. And I get $23.33, 23.33 repeating. Okay, since it's money, I will round, and I'm going to change this to an approximation because it's not exact, and I'll say $23.33. Go back. Okay. How much simple interest does it earn? Round to the nearest penny, which I've done. Okay, pause the video, see if you can do this, check for understanding, and I'll be back. Okay, here we go. How much simple interest? Okay, simple interest. Again, it said simple interest. I equals P R T. I equals P equals R equals T equals. How much simple interest? I'm finding I. Okay, $800 is my principal. 300 days. How many days are in a year? Oh, by the way, it is a non-leap year year. In a non-leap year. In other words, they're not saying 366. It is 300 out of 365. Okay, at an interest rate of 0.0171. Move the decimal 2 places to the left. Pretty simple, yes? That's why it's called simple interest. P equals 800. R equals 0.0171. Time is 365ths. Okay, 300 over 365. You go to your calculator and you say 800 times 0.0171 parentheses 300 divided by, forgot my last zero or I did it too quickly, divided by 365. Close the parentheses, enter. And I got $11.24. And that 3, I'll put 112438 for starters. I equals 11.2438. Round to the nearest penny. So this will be an approximation, and it's $11.24. Okie dokie. Okay, example 6, more of the same, but this one's got a little twist to it, but that's okay. We'll be all right. How much principal? Now we're looking for P. Must be deposited to earn, and it says simple interest, so I'm going to write I equals P R T. I'm going to do this 2 different ways. Okay, so way over here, I'm going to write I equals P equals R equals T equals. I always do this, and then I plug in what they gave us. So it says how much principal, so we don't know P, must be deposited to earn $1,000 in interest. So this is going to be 1,000 this time. In 2 years, which is T, at a rate of 0.013. Easy enough, right? I'm going to show you this way, and then over here, I'm going to do this. I equals PRT. If you know what you're solving for, you can adjust the variables before you begin, or you can just do this and adjust the values as you would in algebra. I'm going to do it this way first. So I'm going to put 1,000 where I is, because that's what that is. Don't know P. R is 0.013, and T is 2. I'm going to simplify this. So 1,000 equals P, and then I'm going to take 0.013 times 2, it's 0.026, right? 0.026, and I'm going to divide both sides by 0.026, 0.026, divide both sides by that 0.026, and divide by 0.026. Obviously, the 0.026 is canceled, leaving P equals, and I go to my calculator and say 1,000 divided by, and since the answer's right there, I always just go second answer, so I'll type it in, and I get $38,461.53. What? 38,461.54. 38,461.54. I rounded. Okay, round to the nearest penny, because this 8 will make this 384.54 cents. Okay, so that's a lot of money. Okay, so now I'm going to do it. Now I'm going to do it this way. So we know we're solving for P. So whenever we know what we're solving for, once we do this and I have this equation, before I even enter the data, I can divide this by RT and divide this by RT, and these go away. And therefore now P equals I divided by RT. Okay, whatever floats your boat, whatever way you prefer. Let me fix this a little bit. All right, so it's P equals I divided by, that's not a capital R, my fault, RT. This is an R. All right, so then we just substitute in, and that would be P equals 1,000 divided by 0.013 and 2. Okay, and then if I enter this in my calculator all at once, all I would do is go 1,000. Since it's all by itself, I hit divide and I put a parenthesis here to make parentheses there to combine the denominator. So there'd be another parentheses, 0.013 for that, and then another parentheses for 2, and then close that all up and hit enter, and I got the same value, 38,461.54. Okay, so there is the answer. You choose which way you want to do it. Neither way is wrong. I don't know. It's up to you. Okay. Pause the video, see if you can do the check for understanding. All right, here we go. So now it says how much principal. All right, so now I already know if I put P over here. Actually, let me go in the order I always do. We have simple interest. We have principal. We have the rate. We have time. How much principal? We're trying to find P. Must be deposited in a 2-year simple interest account that pays 0.0175 as a decimal to the near to of interest to earn $300 in interest. Okay, so I want to make 300 bucks. So you say I equals PRT. And over here, well, actually, let's do it this way this time. Since we're solving for P, we're going to divide both sides by RT. These get canceled. And that leaves me with P equals I divided by RT. So therefore, P is going to equal the I, which is 300, divided by 0.0175 times 2. Okay, get my calculator. 300 divided by parentheses 0.0175 times 2. Enter, and I get $8,571.43. Okay, we're going to round to the penny. It didn't say, but we should round to the penny because it's money. 8,571.43. 8,571.43. And this was the answer we were looking for. Okay, next one says, example 7, Derek has a bank account that pays 2.1% interest. Simple interest, by the way. So as soon as I see that, I write I equals PRT. I equals P equals R equals T equals. The balance is $910. When will the account grow to 1,000? So he wants the principal to be $1,000. So that goes there. But the balance is only 910 now. So the interest is going to equal what he wants in the account minus what he has. So he needs to make $90. 1,000 minus 910 is 90. He wants $90 in interest in order to get to a principal of 1,000. The rate is 0.021, and the time is what we're trying to find. So since we're trying to find time, I'm going to divide this by PR to get T by itself. Divide by PR. These cancel, and I get T equals I divided by PR. Substitute in my givens. T equals I, which is 90, divided by P, which is 1,000, times the rate, which is 0.021. Okie dokie. All right, then I get my calculator, and I do 90 divided by parentheses 1,000, and then another parentheses for 0.021, and enter, and I get 4.2857. So that is 4.2857. I just went out 4 decimal places. It says to round to the nearest month. Well, what is 28% of a year? Okay, so I'm going to say 0.2857 times 365 days would equal 104 days. Okay, and there's approximately 30 days in a month. This is a close enough average, and it comes out to be about 3.5 months. So T is going to be approximately 4.5. Wait, what was it? 4.3 years. Okay. It says round to the nearest month, though. So it would be 4 years and 3 months. It's not quite half of the month, so I'd round down. So I'd say 4 years. Oops. 4 years and 3 months. All right, check your understanding. Pause the video, see if you can do this, and here we go. How long will it take $10,000 to double at 11% simple interest? Keyword here, simple interest. We write I equals PRT. We write I equals P equals R equals T equals. How long? We're trying to find T. $10,000 principal. Doubling is taking that amount of money and multiplying it by 2 or adding the same amount to it. So my interest is $10,000. So if I have a principal of 10 grand and I want to double it, I want $20,000. So therefore I need a $10,000 worth of interest at 11% simple interest, which is 0.11. So we want to solve for t. So I'm going to divide by PR, both sides. The PRs cancel, and I get t equals interest divided by principal times rate. So then I substitute in my givens. Interest is $10,000 divided by the principal, which is also $10,000. And I'm going to multiply that by the rate, which is 0.11. Okay, and then I go to my calculator and I do 10,000 divided by 10,000 times 0.11, and I get 9.090909. 9.09. Okay. It doesn't say years, months, so I would say t is approximately 9 years. All right, example 8 says Carrie invests $5,000 in a simple interest. Simple interest, I equals PRT, I equals P equals R equals T equals, and an account for 5 years. Invest 5,000 is the principal. Okay. What interest rate? Must the account pay? So there is $6,000 at the end of 5 years. So if there is $6,000 at the end of 5 years, remember we already have 5. I need $1,000 in interest to make a, so that there is $6,000 at the end of 5 years. So there'd be $1,000 interest added to the $5,000 principal to get us to 6,000. Make sense? So the principal plus interest has to equal what our goal is. So if we're going to solve for R, we divide by the other two things that are by over there to get rid of them, and that's PT. So I'm going to get rid of P cancels P, T cancels T, and I'm left with R equals I divided by PT. So R equals interest, which is 1,000, divided by principal, which is 5,000, times time, which is 5. And that is going to give us 1,000 divided by parentheses 5,000. I didn't have enough parentheses, timeout. Second, insert another parentheses. Okay, close parentheses, another parenthesis for the 5, and close it. We're done. 0.04. So the rate is 4%. So we answered the question. At an interest rate of 4% in 5 years, we will make $1,000. Okay. Now it says, check your understanding, pause the video, see if you can do this. And here we go. Let's turn to green. Marcos deposited $500 into a 2.5-year simple interest account. Simple interest, I equals PRT, I equals P equals R equals T equals, deposited 500 is principal, 2.5 years is time. He wants to earn $50 in interest. What's the rate? R is what we don't know. So we're going to divide both sides by PT again. Divide by PT. P cancels P, T cancels T. R equals I divided by P, T. So R equals I divided by P times T. Okie dokie. And I put that in my calculator and we are done. 50 divided by parenthesis, 500, parenthesis, 2.5, close it, enter, and that's 0.04. So again, it is 4%. That is our R. Okay. And And that's a wrap.